Great, so let's get started. Yep, I am Stephanie from Lightstep. So we're an observability tool. I've seen a lot of this type of subject matter before, monoliths and microservices, regardless of which architecture you use, you need observability tools. So in this section, we'll be covering the pros and cons of monoliths versus microservices, and the implications of migrating your system over to microservices from monoliths. In this particular part, we'll be covering understanding when it's time to split a monolith apart and tips on how to do that effectively. So a little bit about my background before we begin. So this headshot is pretty funny. It's not my professional one, but that's okay. I look a little mean, I think, but I promise I'm a nice person. I am a solution architect originally. I used to be an engineer. I've worked in consulting before, also worked with serverless a lot. So I've seen a lot of migrations to microservices in my tenure. And at Lightstep, I am a solution architect for our most enterprise accounts. I've definitely seen a lot of the challenges, both organizationally and technically, with making switches over to microservices and what all of that entails. So here's just some quotes across the web that I found of what a monolith is and what a microservice is. I think it's pretty funny how different everyone views these two words, right? So this particular quote, a monolith is an entire application that runs in a single process. I mean, maybe, but it could be multiple processes. A monolith is any system that's not built out of independent microservices. Well, that's kind of a circular definition there. And then the microservice definition here, very small single purpose service that does one thing and one thing only. Not necessarily. That could be a serverless function maybe, but microservices might be able to do more than one thing, I think. So I guess the point here is there are a lot of different definitions here, but these are actually architectural patterns. So there isn't one solid definition. These words mainly exist just to help us understand our architectural choices as we develop our systems. So regardless of whether you want to be pedantic about these definitions or not, these are just architectural patterns, really. So there isn't like an exact definition of either. So first, I'd love to walk through an architecture example just to show everyone both like what a monolithic architecture could look like and what the move to microservices could look like. And this definitely varies a lot because, like I said, there isn't a solid definition of either. They're really just architecture patterns. So in this example, we can think of a backend application hosting an e-commerce website. Here's some of the features that this might handle, right? So add item to cart, checkout cart, promotions and coupons, email notifications, log in and log out. These are all typical features that we might see in an e-commerce website, for example. If we were to use domain-driven design principles, we could say that it handles several models here, including payments, inventory, promotions, authorization, and notifications. So if you're not familiar with domain-driven design, essentially this is principles that are used to describe the entities or database models that you're interacting with to help reason about your system and what it does. You could also maybe consider each of these different features as API endpoints on our backend application, essentially. And here's just a super simplified diagram of what this might look like in a more monolithic architecture. So we've got our API gateway here. And this is where all requests will hit before they go into our backend system, which is this blue box. You can think of this as a single container, regardless of whether you're running microservices or monoliths. In general, these days, you usually run inside containers. So in this case, we've got some of the features that I just talked about displayed here as API endpoints. So add item to cart, buy items, log in, and email user. Each of these different features is going to hit various external dependencies here. And these dependencies could actually be represented in a database. They could be in a third-party API, for example. The whole point here is that these are external dependencies that multiple features rely on, right? So some of these are shared. So add item to cart talks to cart storage and inventory storage to basically keep track of the user's cart, maybe, and to check inventory when you add an item to cart and mark that item unavailable. Buy items, in this case, is talking to cart storage and a third-party payment service. So this could be calling out to something like Stripe to process a more party. And it also talks to the cart storage to figure out what items are currently stored in the user's cart. And again, this is greatly simplified. Here's a login feature. So this is talking to a third party again. Maybe it's talking to Auth0, for example. And it's also talking to our account storage, where maybe we have the username and whether the user is activated or not stored. And lastly, we've got email user. And this could be talking to some kind of SNS provider or email provider to push that email notification or push that text message, etc. And it also talks to account storage to figure out what that user's email is. So why is this called a monolith? Well, essentially, it's all in one container, and it's all running in its own application. There's a lot of shared dependencies here. And if I were to try and scale out each of these different features individually, I could not, right? I would have to scale the whole container and make copies of my whole container every time I wanted to scale. So for example, if the users were hitting buy items a lot for some reason, like a lot more than any of these other features, that would put some load on my overall container instance and maybe would trigger a scaling. But then I'm also replicating all this other functionality as well when I probably would not have to. So that just highlights one of the benefits of having a microservice-based architecture versus a monolith right away, scalability. So here's a more distributed example of what this architecture could look like. Again, I'm just walking through each of these to explain the decisions here and try and drive home basically these concepts of microservice-oriented architecture versus monolith. So maybe in this case, we actually did this split for security reasons. So as you can see, we have login separate from the other functionalities that we previously had altogether. And maybe we did this because we wanted login to be a separate VPC. Maybe we have like a very secure application here where we need a certain separate level of security in our networks. So we have this login functionality separated out with its own authorization process. And you'll see here that I've also split out storage. So this account storage still remains, but now we have this new storage, authorization storage. So one thing that people do usually when splitting out monoliths into microservices is also split up the data storage, because this also means that your data storage is scalable. And here's another example. So let's say we actually have a lot more payment third-party calls than we thought happening, and we need to split out that particular external dependency. Let's say that maybe we also have another feature that's not in this diagram that is calling the third-party payment service a lot and needs to process large batch payments asynchronously. So we wanted to add in some type of queue or something in front of it. So now we've done this interesting split where we still have all of our original functionalities here in this container, but we've split out this particular dependency so that it can scale and so that we can add a queue in front of it. This is just another example Again, this is very simplified, but these are just the kinds of decisions that you're making as you scale out your system. And we've got our final example here. So maybe in this case, we needed to scale out email capabilities. So we separated out the email user functionality from the rest. So maybe we had it to handle email blasts for promotions, for example. We realized we only need that maybe during around midnight because it's a batch process again. And that's when we send out all of our promotional emails. So we don't want to have to scale our whole container during midnight. We just want to scale out the email user functionality. And maybe we also want to make this available for some of our other services or other monoliths or other applications running that we don't see here. In this way, this API endpoint is separate, and we can call it separately from these endpoints, and it's separately scalable. So just some points here. Some of these architecture examples we just saw could be considered partially microservices, depending on whether you want to be pedantic or super like hardcore with the definition, right? Or you could still call them monoliths, right? Because they're not completely separated out. In reality, these are just, again, architecture decisions that we made. And we did this in order to gain certain advantages, but we also had certain inherent complexity along with that. Even just explaining some of those decisions was more complicated, right? So you can imagine in each of these examples, the limitations of the architecture, of the current architecture were reached, and the system was just adjusted accordingly. But again, most of these architectural decisions were confusing and complicated. So the point here is that it's very hard to split a monolith into microservices without really understanding the limits of the system and the overall functionality and how different pieces of your system are interacting with each other. So really just understanding the dependencies, whether you're in a monolith or a microservice-based architecture, is super important here. And in the next webinar, essentially, we'll look at these decisions more in depth and actually look at technology choices and why you would choose a certain tech stack over another when you're doing this kind of migration. So just a note about what it means to build microservice first versus monolith first. So microservice first is just building microservices for new features immediately, and monolith first is building new features into a monolith essentially as a single deployed container first. So as I mentioned, some of these architecture choices were pretty complicated. A lot of times it's easier when you're thinking of short-term velocity and you want to move quickly to build a monolith first, especially if the future functionality needs to be flexible and scalability isn't a huge issue from the beginning. So if you know right away that you aren't going to have to be extremely scalable, sometimes it makes sense to build the monolith first just because you can do that much faster. And oftentimes you don't have to deal with the upfront complexity that comes with microservice first architecture. And when I talk about complexity, I mean there's a lot of moving parts in microservice architecture, and if you don't have the correct level of observability tooling there, it can be hard to understand the context between those different services as they're communicating with each other and understand when something goes wrong, where it's going wrong. Because each of those can almost be a black box if you don't have the right level of like monitoring in place. But I will say in other scenarios, microservice first does make sense. Like for example, if I know that our old payment system is just really slow and it's hooked into our monolith, and I want our new payment system to be very fast and it needs to serve a bunch of other calls from different sources, maybe I just want to build a payments microservice so that it's just scalable from the beginning. And that also is totally fine, and it makes a lot of sense. So again, it's just weighing the pros and cons between architectures and deciding what makes sense for your system. And here's a graphic just to kind of better explain a lot of this. So Martin Fowler is a really great source for a lot of basically a lot of these decisions and a lot of these choices that people are making. It's really also kind of funny looking at Martin Fowler, because you can actually see what the thinking was 7 years from now compared to how it is in modern times, when microservices were just a huge fad. But anyway, we can say as a user, going directly to a microservice architecture, there be dragons, versus allowing a monolith to form and understanding the complexity and the boundaries in your monolith and then breaking it out into microservices might be a happier path. So also what comes to mind here is the whole concept of YAGNI, essentially. So YAGNI stands for you aren't going to need it. So sometimes building microservices immediately, especially building several at once that interact with each other, is not the way to go, because you actually aren't going to need that level of complexity yet. And you may not actually understand basically the full boundaries and interactions that your different features are going to have. So next, I'm just going to dive into just a few myths about microservices and monoliths, just again to clear up these two, or I'm going to run through two myths. So firstly, microservices are synonymous with containers. That's not true, actually. In modern architecture these days, everyone practices containerization, regardless usually of whether you're building a monolith or a microservice. And that's just recommended, both for the benefits and for velocity and deployability in modern cloud systems. So regardless of your cloud provider, most people do opt for containerization just as a best practice. And I will say in general, most best practices for DevOps and site reliability in modern applications apply for both monoliths and microservices. So it doesn't really matter which type of service you're building, whether it has, you know, a lot of functionality split out or whether it's all built into one container. You should still practice containerization. You should still have an external configuration store that, and also, for example, continuous integration to deploy your containers, etc. All of that still applies. Here's another myth. It is much easier to build a monolith than a microservice. You need less technical and architectural skills. So this may be somewhat true, but in general, you still need the same amount of technical and architectural skills. So you might need less infrastructure operation skills, and that's just because you may not need to deal with different types of containers and deal with different scalability policies and load balancing, for example. You may not need to deal with as much distributed state. That's because you won't have the state spread out across different microservices. Ideally, people say microservices should be stateless, but I think in practice, that's not necessarily true. Sometimes they do have state, even if it's just temporary. So there is still inherent complexity that you may not have to deal with, but you still need the same base technical and architectural skills. And that's because best practices like modularity, shared libraries, various testing structures, etc., are important regardless of what you're building. And this is also, these best practices are also important because they protect us from not being able to understand our dependency structure. Because again, regardless of whether we have a monolith or a microservice, we really need to understand what the dependencies are in between all these interacting pieces of our code and make maintainable code, or else we're going to end up in a bad spot. And especially if you are building a monolith and planning on moving to microservices afterwards, you do want to have modularity and testing structures, etc., in order to understand when you break those dependencies as you split out into a microservice architecture from a monolith. It makes the split a lot easier. Now I'm just going to go over some general comparisons. So this is pretty straightforward, right? Monolithic versus service-oriented. And I say service-oriented again because you could call them microservices, or you could say it's more service-oriented. In modern times, people like to say service-oriented sometimes versus microservices, but you can consider it the same thing. In monoliths, code modularity, despite that being a best practice, is not always followed. Whereas in microservices, we do tend to see a more modular code base. Functionally, monoliths are not modular because those functionalities are all in one application, in one container. They are not split apart. So therefore, the functionality is just not modular. Whereas in microservices and service-oriented architectures, this fosters much more modular functionality, even if a microservice or service-based system has maybe 2 functionalities per container. That's still more modular than what you see in a more monolithic type of architecture. In monoliths, velocity in general tends to be slower among distributed teams. So this is something that we actually haven't talked about yet. In distributed teams, working independently, it can be hard to all work on the same exact code base and the same exact monolith because there's just a lot of coordination that needs to happen there. Whereas with microservices, this can be more ideal for distributed teams just because teams can function independently without constantly having to worry about breaking different dependencies or different areas of the code that another team is relying on. And monoliths are not independently scalable. So again, as we saw in that architecture example, if we want to scale one piece of functionality, we have to scale the whole monolith every single time, and this can get costly and not maintainable. Whereas with microservice-based architecture, this enables more scalable functionality where we can just scale one portion of our system instead of scaling the whole thing. Monoliths also tend to have more shared ownership, which also means a greater chance of accruing tech debt, just because no one person owns any part of the system. So therefore, you know, the overall health of the monolith is more shared, but that just means also that because it doesn't foster that more individual ownership as microservices do, there's just greater chance of letting things get old, accruing tech debt, having less testing within your monolith, etc. Monoliths also are more difficult to create as fully fault tolerant. So there's more chance there of cascading failures. And again, that's just because in a monolith, there are a lot more dependencies between different features and different functionalities. So if one portion breaks, there's much more greater chance of having a cascading failure. Whereas with microservice-based architectures, it's sometimes easier to build with more fault tolerance. So let's say we have a certain, for example, like a certain third party that we know is sometimes very slow and sometimes needs to, or sometimes goes down, let's say, or something like that. And when that third party goes down, maybe our microservice that is talking to that third party also goes down, but we can just have it spin back up. It's much easier to have that microservice be a separate piece of functionality and have it just have a restart policy that basically contains the failure there to just one portion of my system, and having a monolith where if one portion fails, maybe it crashes the whole container. And when I talk about fault tolerance, there's planned fault tolerance and there's unplanned fault tolerance, right? So a lot of times when these issues come up, they aren't things that we actually planned for. They're just things that happen, and we need our containers to be resistant to it so that we don't cause cascading failures. And lastly, again, with monoliths, sometimes in the short term, this allows for faster velocity within a single team. So microservices by default tend to be more complex, and that's just due to having distributed state and distributed functionality. Even if there isn't any state in your microservices and they're stateless. There's still state somewhere usually, even at the data store level. And sometimes this is hard to understand, especially when trying to diagnose failures where you don't know which actual service was the one that caused the failure, for example. And we see this even more with serverless, actually. So not saying that serverless isn't great, because it is, but serverless-based architectures take this a little bit to the extreme where there's no state anywhere, and it sometimes causes hard to diagnose failures if you don't have the right level of contextual observability. So next, I wanted to discuss here some key signals that I've seen before in my experience that indicate when it's time to split a monolith apart, especially if we're building a monolith first. So lack of maintainability is probably one of the biggest ones. Basically, this happens when no one fully understands the complex relationships between different parts of the code base, and it's becoming slower and more riskier to build new features or services and successfully integrate them. Maybe even your individual engineers are starting to put up red flags because they feel like it's so risky to deploy, and you're avoiding deploying on Fridays because who knows what might happen. And even things like straightforward upgrades to library versions are challenging and time consuming, just because, again, you don't understand all the dependencies and you don't know what might break. So this definitely can happen even if we're following those best practices with the modular code base. Lack of maintainability is just a fact of life in code. Eventually, it just happens unless you are really on top of tech debt. But with monoliths, it happens to the extreme, and it definitely is one of the reasons why people like to split into microservices. Just because even just refactoring the monolith can be a huge process, like a huge undertaking, when it's much easier to just split out that old functionality. So concerns with scaling and fault tolerance. When portions of functionality begin to air out, unrelated portions of the system go down as well. This is one of those signals, again, that it's time to maybe switch over to more microservice approach in your architecture. If the monolith holds state, for example, maybe recovering from crashes is really complex and time consuming. So this even I've seen at companies that I worked at as an engineer. Basically, we had an old monolith that just held a certain portion of state, and every time it crashed, we would have to spend quite a deal of time just basically reproducing what state it had before in order to not break the whole system. Definitely not ideal. It's not fault tolerant at all. Finally, parts of the monolith are receiving larger volumes of traffic, are performing CPU or memory heavy operations, making it hard to scale for all functionality. So again, this is that same issue we saw when we were looking at that original diagram of architecture. In that example, it becomes hard to scale certain pieces of functionality because we are just duplicating that container over and over. And it has several pieces of functionality there with different bounds on its scaling, right? So some functionality may be memory bound, some may be CPU bound, some may even be network ingress bound. Maybe you even have data stores that are causing the bounds. So for example, too many connections or things like that, and that's what's really causing the bound. Regardless of where you're seeing those scalability issues, that oftentimes is an indicator of when to split up that piece of functionality from the larger monolith. So another key signal here is organizational growth. And I will also say, in addition to growth, it can also be like a signal can also be organizational change, essentially. When engineering teams are expanding and new teams are spinning up, or maybe becoming more distributed across product features, for example, or across regions even, it becomes easier to work on your monoliths into microservices. Team can have ownership of certain services without owning the whole thing. So another signal here is when the building velocity is just slowing down due to the amount of coordination that's required to build. So maybe certain teams are constantly having to meet all the time to not step on each other's toes when they're developing features. It's a good time for a split, possibly. And again, another indicator is just lack of parallelizability, essentially, because underlying functionality is just so intertwined in that monolithic-based architecture. And here's just some advice at a high level of preparing for this split, just so you're organizationally ready for it. And this doesn't all need to happen. And you may have actually already figured out a lot of these different tasks in your monolith before to microservices. But essentially, each of these different tasks here needs to be scalable and repeatable across different teams. Because as you start encouraging people to split pieces off your monolith, they need to be able to perform all of these different steps without breaking your whole system, right? So firstly, a standard automated deployment process with the ability to add or remove containers easily. This is super important. This is just basically figuring out how the developer operations is going to work. I see these days a lot of teams actually own the DevOps as well for their services. And a lot of times there isn't like a set DevOps person anymore in organizations. So is going to need to own this deployment process. It's important to have it figured out ahead of time so that they don't have to deal with that unexpected complexity when it's time to start splitting up services. Auto-scaling and load balancing capabilities, this is kind of a given. Usually most cloud providers these days do have these capabilities, but the key part here is understanding how to configure these capabilities in a scalable way. So maybe you need to change the auto-scaling policy, for example, for a particular service, or adjust it, or you need to just also adjust how your load balancing works, for example, or keep that somewhere. Just understanding how this is going to work, maybe even just using Terraform or something like that is important, because otherwise it's kind of hard to maintain and it's easy to break. And lastly, I would recommend creating some kind of step-by-step on how to create a new service for your developers. So for example, how to add a new service configuration into the deployment cycle, how to set up secrets and permissions, how to set up alerting and monitoring, maybe even also how to configure having that service talk to another service, right? Because if you're splitting up a certain piece of functionality, maybe it needs to also talk to some other service elsewhere, or needs to talk back to your monolith, etc. That's another one of those gotchas, right? So really the recommendation here is to have a spike to document how to do these tasks within your cloud provider and understanding the limitations there before your team starts writing microservices. So really you want maybe even just having like one team experiment with all of this and figure it out first is the way to go. But otherwise what I've seen here is this organizational wide, okay, time to split out all of our services, every team, go do it. And they all figure out all of these different steps independently and have their own processes for it. And it leads to just a lot of complexity in your architecture and lack of across different teams. And on setting up observability for these new services, this is actually very important. So in monoliths, it tends to be kind of easier to monitor them, especially if you're using one of those older tools like New Relic, APM, for example, just because it is built for monoliths, essentially. So usually people building monoliths are used to that kind of observability tooling, but once you start splitting into microservices, you may find that your current observability tool is harder to scale. Maybe it's harder to handle high throughput. Maybe they charge you a ton of money for every host, node, or instance. So I've seen it even explode, like moving to serverless, because you have a lot of ephemeral serverless functions. Adding observability onto each one can lead to a cost for literally every single function run. And that is just crazy. So definitely make sure your observability tool is going to be able to handle basically a more distributed approach to monitoring. And really what's key here when figuring out how to set up your observability for your microservices, the key here is to have that observability tool be able to understand context between distributed systems, just to help find those crazy bugs that are happening throughout your different services, right? So even if you just have metrics and logging, that doesn't always cover the interaction between different services. Lastly, you probably want some kind of tooling that isn't time intensive to instrument and isn't limited on data volume or cardinality. So this is another thing that I've seen before. So as you're scaling out into microservices, you also are adding increasing complexity, increasing cardinality in your observability solution. And a solution that does charge on cardinality can definitely explode here, just because you have too many services running with their own functionalities, right? Because we split everything up, and that is not fun to deal with. So with that being said, let's start with Q&A. And I will also add just like a short plug here to try out our solution, lightstep.com/play. Lightstep is basically an observability tool that includes both metrics, logging, and tracing all together, and is able to handle these type of issues because it's built by people who have understood how to split a monolith apart and understand the complexities between microservice architectures and distributed systems in modern times. So awesome. Now I will switch over to Q&A.
Yeah, okay, great. So we've gotten some questions in, but if you do have a question for Stephanie, please go ahead and use your GoToWebinar control panel and submit your questions. And why don't we go ahead and start with this one, which is, what's the best first step to begin a migration to microservices?
Sure, yeah. So the best first step, I would say, to begin migrating is understanding dependencies in your monolith first. So make sure that you understand the boundaries in functionality in your monolith. And for example, if your monolith is not operating with RESTful APIs, this can also help. Creating RESTful APIs in a layer on top of your monolith will help you understand where your functionality is intertwined and where it makes sense to do a logical split. And this is also where things that include tracing come in handy, because distributed tracing helps you understand your dependencies regardless of whether you're running microservices or monoliths, and understand where you can split certain functionality in a safe way.
All right, great. Okay, our next question here. Our applications are largely built on a monolith and we don't plan to migrate to microservices, at least not in the short term. How can we best leverage observability?
So I would say, again, in this case, understanding dependencies is still critical. In a containerized world, even without microservices, we're still scaling copies of the monolith based on understanding different load and where that's happening within our different functionalities in our monolith. So how do you really understand where the different load is coming from in our monolith, and how do we keep it healthy? Still understanding dependencies, and if the dependencies aren't clear in that monolith, then it's basically an Achilles heel. So just trying to keep the complexity under control, even if you aren't planning to switch. And that's where leveraging an observability tool that can handle basically understanding the amount of complexity there effectively. So if you just have metrics and logs, for example, you may not understand how your system is interacting internally anyways. Like where are your boundaries, for example, between your different libraries? When are certain libraries used on certain code paths and when are they not? That kind of information really relies on a more complete observability tool that includes tracing as well, is what I would recommend.
All right, excellent, great. Next question here. If you build a monolith first, Are there things you should do during the initial development to enable breaking the monolith into microservices later?
Yeah, so that's definitely a great question. I would say modularity is super important. So again, all those best practices where we practice like a dry code base and we have all of our libraries clearly split is super important. I would also encourage people to include tracing right away. So obviously I'm at Lightstep and we're a big fan of tracing, but even before this, I was always a huge fan of tracing because it allows you to see where your dependencies are. So if you're building with tracing in mind and with modularity in mind, basically that will enable you to make the split a lot easier because you'll be able to see where certain modules are being used for certain functionality, and the splits will become more clear versus if you're not able to understand the dependencies in your monolith.
All right, great. Boy, we've got some really great questions in so far, but there's plenty of time. If you have a question for Stephanie, go ahead and use your GoToWebinar control panel. Our next question is actually more of a comment. I think on the benefits of microservices. It's worth mentioning faster build times and faster feedback on the positive side, and the ability to reduce spend on the build platform. I guess he wanted to give his 2 cents. Do you have any thoughts on those?
I mean, I definitely agree. I think it is worth mentioning. So yeah, you definitely do get faster build time and feedback with microservices versus with a huge monolith. I think that is definitely a part of velocity there. And even also, I will say, going even from microservices to serverless, this becomes even more obvious. So serverless actually gives you even faster build times and faster feedback cycles, and also reduces the spend even more on the build platform. So this is definitely true. As you continue to split out functionality, the feedback loop does become much smaller.
Okay, great. Next question, I think I'm going to get it right. Is splitting the code before data a best practice?
Splitting the code before data. So I'm not sure if I completely understand what this question is asking, but
okay.
If I'm interpreting it correctly, I think it's saying basically splitting up a code base, but relying on the same data store, like is that a best practice? I would say, again, it just depends on what your architecture needs, right? So if you're overloading your data storage and you're seeing a lot of, connection pool full, or your SQL database is just not able to handle the load anymore because you're using it for the wrong reasons, then it might be more important to figure out a split on your data storage before figuring out a more microservice approach. And you might even just have to do that together. It depends, again, on the needs of your architecture.
Okay. All right, great. Next question. How can we store data in microservices, in the one or in multiple databases? Currently, we have one big database.
Yeah, it's a good question. I think it's definitely sometimes fine to rely on the same database across microservices, as long as that database can handle the load, essentially. So you really start seeing issues when basically the database starts falling over, or it's not meant for the particular use case. And then that's when you probably want to do a split on databases. So maybe one big SQL instance is fine for like basic data, like account storage in that example that we looked at. But maybe we have something with much higher throughput that will need something like AWS Dynamo DB, for example. Then it makes sense to spin up another database in Dynamo to handle that kind of throughput and that functionality. So your data storage choices don't really depend on your microservices exactly. Again, it's just an overall architecture decision. But I would say that I would err on the side of splitting up your database storage or your data storage when those access patterns make sense for the split.
All right, excellent. Well, I can't believe how good these questions are that have come in, and we still have a few to go, but there is plenty of plenty of time for questions. So if you do have one, please do send it in. Okay, the next question here: is it fair to say that microservices is more an architectural style than a single pattern, and that the paradigm spans software infrastructure and other areas?
Yes, it's totally fair, and I completely agree. And honestly, microservices is a loaded term these days, but really it's about architectural styles in modern architectures that need to be distributed in order to handle basically the access patterns and load and the distributed teams and all of that. So yeah, it's basically an architectural choice or orientation as you're building. It's not really a single pattern, I guess.
Okay. Next question here. Do you have any recommendations on handling the migration and splitting the monolith database across microservices?
Good question. So I would say definitely understanding what pieces of that monolithic database it makes sense to split. And then I think this question is basically asking like how to handle the migration of data if you need to move to several different databases, for example. So I would say basically you just rely on that old database as read-only and then start switching over to the new database for a certain percentage of traffic, for example, and then basically observing that. So essentially, I would create the new microservice if you haven't already, and then start routing a certain portion of your traffic over to the new service and over to the new database, and then basically observing to make sure that it looks like that's going to be okay and it's handling it correctly and there aren't any bad red flags or errors happening, and that the access pattern is correct and the like the data architecture is looking good, and then I would completely move over eventually. So that's basically just using basically the capabilities of moving only a certain part of traffic over are useful there, whether you're using like feed or A/B testing or anything like that, or just canary deploys. That's how we do it internally at Lightstep. So we found it to be very useful.
Okay, all right, great. Next question, do you have a preferred approach for dealing with quote unquote transactions that span across multiple services?
Yeah, so dealing with transactions span across multiple services. Yeah, I would say this in general can look like a fan out in your code. I think that relying on observability tools is my preferred approach for this particular scenario. For example, at Lightstep, I had to spin up a new service recently that spanned transactions across multiple services, that functionality. And I immediately built with tracing in mind first, and I was able to actually see, even in our staging and testing environments, where those dependencies were going and how long those different transactions were taking that I was kicking off from that parent service. And it just gave me like a more holistic view when I was building out that basically that new feature. So I would say that's my preferred approach, is to go observability first, so that I know what I'm actually like, what my load is going to be on that feature to other multiple services that I'm hitting. And yeah.
Okay, all right, great. All right, we are about 10 minutes to the top of the hour, so I think we have time for maybe 2 or 3 more questions. Let's see, how about this one? How do you coordinate microservices effectively across a microservices sprawl, such as API gateway or service mesh?
How to coordinate microservices effectively. So I'm not exactly sure about what this is asking regarding coordinating them, like whether it's coordinating their deployments or whether it's coordinating how their performance is. So this question, I'm not super clear on, but I will say, again, that basically observability tooling can come in handy here, especially if you're using a service mesh. It's very easy to just add tracing onto your service mesh. So for example, if you're using like Envoy or Istio or Ambassador, or in your API gateway, even if you're using Kong or Nginx, things like that, you can actually turn on tracing with like a flip of a switch there, whether it's reporting to Lightstep or Jaeger or Zipkin, etc. It's super easy to do that. And then from there, you can actually see what your microservices are doing and where transactions are going across services. And that really will help you with coordination, I would say, just to give you a lot more understanding of where your dependencies are going.
All right, great. Okay, next question here. What about configuration management when it comes to microservices? Isn't there an increased overhead cost in your environment? And how does one go about dealing with this?
So if this is talking about deployment configuration management, I would say the overhead cost in that case is minimal, at least because from my experience anyway, I've always relied on Terraform for a lot of my configuration management. And that tends to be pretty straightforward and declarative. And you're able to constantly basically have the state of your infrastructure and where your configurations are in your Terraform or in your Helm charts, if you're using Kubernetes and Helm, along with Terraform. So I would say the overhead cost in that case isn't huge, but that's how I would go about how to do configuration management. So that's my answer to that question. I'm not sure if it's completely what the person was asking though. So
okay, all right, great. Let's see. Let's look at this question. How do we know if our microservices are too fine-grained?
So if they're too fine-grained, well, if they're too fine-grained, maybe they're actually better as serverless functions, right? So I think it's not a bad thing for them to be too fine-grained. I guess the downside there is that you're spinning up whole containers maybe for some single piece of functionality that's very stateless. And in that case, I would almost, again, recommend Lambda functions or serverless functions for that use case. If it's completely stateless and doesn't need to run longer than 30 seconds, then it might be better as a serverless function or as a set of serverless functions, basically with an API gateway, just like directing the endpoints to the right serverless function. So basically, I would say the indicators there again are if it's running in less than 30 seconds and it's extremely stateless, and also maybe if it's very high throughput, then it might be better as a serverless function.
Okay, great. We're about 6 minutes to the top of the hour. I think we have time for one more question, then we'll close it out. And this one is kind of a big one. When moving from a monolith to a microservices architecture, how do you recommend to handle the migration? Which functionality should we focus on first if we cannot migrate everything as a whole? And should we develop or migrate core functions first, or better focus on less priority functions?
So if you have not done it before, I would say focus on something with a little bit less priority, just to make sure that you are getting it right when you spin up that microservice and you understand all of those things that I mentioned, like how to handle configuration in your new microservice, how to handle auto scaling, etc., and use that as like a lower risk, basically, example of a microservice, and then from there focus more on core functionality. But sometimes it's so critical to do the split that you don't have time to focus on something less critical. And in that case, I would say that's okay too. Just make sure to rely on both your observability tools and on best practices like using canaries and things like that. Only direct a certain portion of traffic first to your microservice and see how it works and what's happening there. And just to better understand when things are breaking, just to lower the risk there. So again, it kind of depends, but I would say if you've never done it before, probably focus on a less priority functionality first before migrating core functionality.